Hi everyone. In the last two lessons, we talked about the inductive effect and the resonance effects. Both of these fall under the bigger concept of electronic effects. All right. So in this lesson, we are going to combine these two concepts together to explain the stability of intermediates. Okay. So for our intermediate in this case, all right, we are using our carbocation ion. All right, so these three things are our carbocation ions. Okay, so we want to our job is to determine if the intermediate is electron rich or electron poor. All right, so we know that carbocation ions and radicals are electron poor because this carbon atom, all right, to achieve octet structure, okay, it needs 8 valence electrons. However, it only has 6 electrons. Likewise for a radical. Okay, now it has 7 electrons, even though it needs 8. So it is electron poor. Alright, so what we want to see is that the more, if it's electron poor, we want to make sure that it becomes less poor to stabilize it. And if something takes away electrons and make it more electron poor, alright, it destabilizes it. Okay, so let's take a look at this example here. Alright, so we will use this first molecule as a benchmark, alright, because it only has protons or hydrogen atoms connected to it. So in the second example, we know that there are 3 CH3 groups attached to it, so it is electron donating. This is what we have learned in the inductive effect. We know that alkyl groups or these alkyl groups are electron donating. All right, they are mildly electron donating. So since it gives uh, electrons to this carbocation ion, it helps to disperse that positive charge because electrons are negatively charged. Okay, so it puts electrons in. All right, so if you take a look at the last example, okay, we know that it has 2 electron donating alkyl groups, and at the same time, we also learned in the previous lesson on delocalization that the electrons in this ring, all right, actually flow out into this carbocation ion. Right, so this ring's electrons will flow out here. So this actually allows a stronger stabilization of this positive charge. All right, so that is why if we were to compare these two, okay, the benzene ring, right, will have a greater effect on our carbocation ion. Alright, so just by looking at this, the most stable intermediate is the one on the right. The second most stable is this, and this is the least stable intermediate.